Hello, Set 1. Welcome to your first HBL pre-recorded lecture. My name is Miss Lee. So, today I will be taking you through your new chapter known as the particular nature of matter. Now, your previous HBL lesson last week on Thursday, you would have tried your hand at the SLS activity, talking about mixing 50 cm cube of water with 50 cm cube of alcohol. Now, you will notice that in the video that the volume that was left, the total volume was actually less than 100. So some of you may have questions like, why is that so? What happened to the balance of maybe 4 to 5 cm cube of solution? Where did it go to? So we hope that by learning this chapter, we will be able to see matter in terms of models because of the various reasons that models offer us, the advantages of models. Okay, so for today, we'll be looking at 7.1 and we'll be looking at 7.2. All right, so let us start. Okay, so, right, so we know that all living things in this world are made up of matter. Okay, for example, this kitty container here, which is a non-living thing, also has matter. Okay, this kitty container over here, all right, and Miss Lee, who is a living thing, is actually made up of matter. Now, all objects in this world, whether they are living or non-living, all take up space and they all contain matter and they all have mass. So you may want to take your pencil here and take down notes because Misty is just going to explain to you what is the meaning of mass. All right, so mass actually means, all right, the amount of substance, all right, in an object. So whether you are talking about a living versus a non-living thing, all living and non-living things will have substance inside it and therefore will have mass and therefore take up space and therefore are called matter. So this bottle of alcohol hand sanitizer, when I put it on the table, it occupies space because although it is a non-living thing, it contains mass. Okay, and therefore it is called matter. Okay, so I also want to mention that at any point of the lecture, if you feel that you need to pause the video because it's moving too fast, then you can pause and you can write down notes. Now, there are three main states of matter: solid, liquid, and gas. Now, all things, majority of living and non-living things in this world can be classified into solid, liquid, and gas. However, there are actually two more states of matter, and they are known as plasma, okay, and Bose-Einstein condensate. Now, these are two other states of matter which are not in your syllabus, but you may be interested to Google what are these states of matter, but we're not going to discuss about it today. Okay, so we generally classify matter into three main states: solid, liquid, and gas. And we want to say that all solid, liquid, and gases are actually made up of small, discrete particles. Now, these particles, we will use a circle to represent them. And these particles are known as discrete because they are separate particles. So we draw them separate from each other. So they are clear, discrete particles. Okay, and the thing about these particles is that scientists have discovered from many different experiments that they are in constant and random motion. Now, constant means they are constantly moving, and how do they move is basically very random. Okay, there is really no fixed way to say it. They will move from left to right or right to left or up and down. So they are constantly moving and they are moving in random motion. Okay, now these small discrete particles are actually known as the particular nature of matter. Now in English, nature actually means the way something behaves. So the way solid, liquid, or gas behaves really depends on these discrete particles. Okay, so scientists actually came up with a model known as the particulate model of matter to sort of like make it easy for us to see the nature of matter. Because if I were to ask you to look at a remote control, okay, and I say that, oh, this remote control is made up of solid particles. I want you to see these solid particles. It's going to be very difficult to see with your naked eye. So the scientists actually made it easy for human beings like us to visualize, okay, solid liquid gases by coming up with these models. So these models are known as particulate models of matter. Just like how when you use model drawing in maths, you use small rectangular blocks to represent 4 cupcakes lah, 3 cupcakes, 2 oranges, or 40 apples, because it allows you to see or to visualize. So why, see Jackie Chan's asking, but why? So why models? I thought that PSLE no more already. I don't have to think about models anymore, right? So basically the models were created. Okay, why were they created? Number one, to help us to visualize. Visualize means to help us to see how these particles are being arranged. And when we see how these particles are being arranged, then it will help us to make connections or to say that, oh, is that why solids have got a fixed shape? Oh, because the particles are like that, is it? Yeah, so it helps us to understand properties of matter better. So when we talk about properties of matter, we're talking about volume, we're talking about shape, we're talking about density, we're talking about whether they can be compressed. Okay, so these are all properties that we will mention later on. Okay, so I would just like to show you this particular animation. Alright, so again, we are going to use small discrete particles to represent solid, liquid, and gas particles. Alright, so over here you can see, okay, you can see, I'm going to show you, these are your solid particles. Now you can see that your solid particles are made up of small, discrete particles. Now look at the way they are being arranged. They seem to be like glued together, right? Stuck together, so poor thing, they can't move around each other. They look like a square block. Then you might ask me, oh, is that why solid, the shape doesn't change? Yes, you see, you put this solid particle inside this long cylindrical container. If the solid particles can change its shape, then it will be the shape of this container. But it's only occupying this space here. Why is that so? Because you look at the way the particles are being arranged, they seem to be arranged. Are they very far, or they seem to be touching each other? Good. They are actually touching each other, so they are quite closely arranged. Huh? Okay. Next, let's look at your liquid particles. Look at your liquid particles. Your liquid particles seem to be moving in a very different way as compared to your solid particles, right? They seem to be sliding past one another, and you can tell that they are not so fixed. They are not so like stuck, or in a square shape. They seem to be moving in a very free manner, okay, sliding past one another, and they seem to have a little bit more space in between them, but still relatively closely arranged. All right, now let's look at your gas particles. Look at that. They seem to be moving very freely around this container. They are very far away from each other. They seem to be free as a bird, right? They seem to be moving away and bumping into each other and bumping against the sides of the container. So we are going to be looking at what happens when you pour this container of solid out. Look, the shape doesn't change. It's still in a fixed position. The particles are still very close to each other and it's not changing its shape. Now look what happens when you pour the liquid particles out. Look, you notice the liquid particles, the shape is relatively different. It seems to be sliding past each other, but the particles are still close together and they are still vibrating, but they are moving in a relatively random manner. That means you do not know whether they are moving right or left or top or bottom, so it's very unpredictable the way they are moving. Now watch what happens when gas is being poured out of the container. You see, it doesn't stay in one position and it slowly moves away because the particles are so far and they are moving so fast from each other. So, what does that tell us about the movement and the arrangement of solid, liquid, and gases? So let's move on to page 2. Now that we have talked about the usefulness of the particulate model of matter that allows us to visualize, okay, something that we can't see with our naked eye, we can't see solid particles, liquid or gas, but scientists have come up with models to allow us to represent these gases and liquid and solid particles. We have a common rule, okay. I will now ask you to take out your pencil because you're going to be practicing drawing circles. Okay, now these circles are going to help us to represent the particles in the matter. We are going to practice the 369 rule. Now what does that mean? That means in order for us to draw solid particles, we must have 9 particles. Okay, to draw liquid particles, you must have 6 particles. And for gas, we usually have 3 particles. That's why 3, 6, 9 rule. So now you are going to take your pencil and you're going to draw what exactly you see in the screen that will represent either solid, liquid, or gas models. So for solid models, you will draw 9 circles. Now these 9 circles must be neatly drawn. The sides are touching each other and they are not overlapped. Okay, so there are 9 circles and you notice they are very close to one another. They are touching each other in a fixed pattern. You can see, right? They are fixed pattern because what is the meaning of fixed means they are in the same position all the time. All right, so you may want to pause the video here to draw your solid particles. Okay, welcome back. So what about the particles in liquid? So we will use 6 circles to represent the particles in liquid. Okay, so you can see that if you compare the liquid and the solid particles, the liquid particles have got slightly more space in between them. Okay, slightly, but they are still quite close to each other. Okay, and however, if you look at the way they are arranged, there's no pattern that they are arranged, right? Over here, they look like they are arranged in a square shape, but here, the shape is like neither here nor there, right? So we say that this is a very irregular pattern. Okay, irregular pattern or irregular arrangement. You may want to pause the video here to finish drawing your liquid particles. Alright, now let's look at your gas particles. We will draw gas using 3 particles. Now if you look at solid, liquid and gas, then you can tell that gas will have the most amount of space in between the particles. Okay, you can see that the space in between the particles are the most for gases. Okay, here you can see the space is quite a lot here. Okay, and there are only 1, 2, 3 particles, and the particles are not touching each other. Unlike your liquid particles, 1, 2, 3, 4, 5, and 6. Here you have 9. Okay, so you can tell that they are randomly arranged and they are very far away from each other. So because of the way these particles are arranged and the way they move, later on we will learn, this actually explains the properties of solid, liquid, and gas. Alright, so that's why scientists actually allow us to draw models so that these models will allow us to represent the properties of matter better. Okay? Alright, so now let's talk about this part here in page 2. Now this is a very important part. You must be able to memorize this and to remember this because these are all the keywords that will give you marks during the exam. So we always group the characteristics of particles into 2 main groups. The way they are arranged and the way they move. So we must always talk about arrangement and movement. And arrangement and movement are very different. Okay, arrangement is how they are drawn. Okay, how they are positioned. Okay, that is their arrangement. Okay, movement is how do they move? Do they move fast? Do they move slow? Do they slide past one another? Do they only vibrate? Alright, so you must remember that these two are actually different characteristics. Always arrangement and always movement. So whenever you write your answer in a structured question, you must ask yourself, have you talked about arrangement and have you talked about movement? So let's talk about solids. Solids are very closely packed from the shape here, okay, and they are in a very regular arrangement. Now movement, they actually vibrate about fixed positions. Okay, they don't change their positions at all. Now what do I mean by this? I'm just going to show you a short video and then you'll be able to see. Okay, so this is a fixed arrangement. Now I want you to stare at this particle that I'm pointing to. Okay, the one with my finger, I want you to stare at this particle. Now you notice that this particle doesn't change its position at all. It is still here, although it is vibrating. And the way it's vibrating, there is no pattern to the way it's vibrating. So it's still relatively random, but it's vibrating about its position. That means it doesn't change its position. If it stays there all the way. And because of that, we say that solid has got a definite shape and a definite volume. They have a very high density. Okay, that is why when you drop an iron ball into water, it sinks. It's got highest density amongst your solid, liquid, and gases. Later on in the second part of the lecture, when we talk about expansion and contraction, then I'll talk about why density is a related concept in this lecture. And solids cannot be compressed. No matter how much you press it, you cannot compress it you cannot compress it at all. Okay, so what about liquid? Now if you look at this model over here, your liquid particles are still close together, just similarly to your solid particles. The only difference is that there's slightly more space in between them. So we say that liquid particles are still closely packed and they have a very irregular arrangement. Why do I say it's irregular? Now if Miss Lee were to use my pen here to draw for you, then maybe you will be able to understand. See, if I were to trace the arrangement here, it's like a square, right? But if you look at this arrangement, there is simply no fixed arrangement to it, okay? So we say that it's in a very irregular arrangement and the particles actually move freely, all right, randomly, and they slide past one another. Now this is very important. You might want to put a star here because whenever we ask you questions like what is the difference between the movement of solid and liquid particles, you must say that, oh, solid particles, they vibrate about a fixed position, so the particles don't change the position, whereas in liquids, oh, the particles can actually move from one position to another. That's why they can slide past one another. Okay, so let's watch this video, then maybe you'll be able to understand. Now I'm going to change from solid to liquid. Now look what happens to the liquid particles. If I were to point to one particle and I ask you to follow the particle, it's very difficult because the particle is actually moving from one place to another, unlike your solid. Okay, so we say that liquid particles are actually moving randomly, sliding past one another, okay, although they are still relatively closely packed. Okay, and because of that, they have no definite shape. Okay, so again, let's have a look at this. They have no definite shape. They have a definite volume. That means their volume doesn't change. The only thing that changes is its shape because they can slide past one another. So that is why if I were to look at liquid in this versus this water bottle here, okay, liquid can actually take the shape of the two water bottles here. All right. So we say that liquid has got a lower density than solid, and liquids cannot be compressed. All right. Later on, I will explain to you what is the meaning of compressibility when we finish talking about gas. Okay. So let's talk about the arrangement of gas now. We say that your gas, if you look at this model over here, what can you tell? Over here, the particles are touching each other. Here, still touching. Here, are they touching each other? I can hear no. So therefore, we say the particles are far away, far apart from each other, and they are irregularly arranged. That is arrangement. So what about movement? Movement means how they move, right? All right. So particles actually move freely, very similarly to your liquid. They move freely. They also move randomly. That means there's no fixed pattern to the way they move. They don't all move to the left or all move to the right. Okay, they can move left, right, right, left, right, right, left, left. You know, it really depends. All right, and they are actually moving at very high speeds. That means they move very quickly and they are always hitting against each other. Okay, so now let's look at the model of gas. You see the way it moves? Look at your gas molecules. So I'm going to push it down again. Look, when I bring up, you can see that they are moving very fast and very far away from each other until eventually they can escape the container. So because of this, we say that gases have got no fixed or definite shape. Definite means fixed, and they have no fixed or definite volume. All right, they have the lowest density compared to solid and liquids. Now, gases can be compressed. Now, in order for something to be compressed, there must be large spaces between the particles. So if you look very carefully at your solid particles here, there's not a lot of space in between your solid particles. So you cannot push the solid particles close together anymore because they are very close together. They are already next to each other. No way for you to push them anymore. For liquid particles, the particles are also still touching each other and they are still quite close. So you can't push them. But if you look at your gas particles over here, there seems to be some distance, right? So you see, because there are spaces between the gas particles, all right, you can actually push the gas particles close together. So at first, they are quite far away from each other, far apart. You can actually push the particles together. Now, the ability to push the particles close together is known as compress. So if you can push the particles close together, that means you can compress it. So therefore, gases, because of the large space that exists between the particles, it can be compressed. Alright, so let's move to page 17 of your concept map, which is probably the last page of your notes. Let's complete the concept map to summarize whatever that we have just learned in 7.1. We say that the particulate nature of matter is basically a model that scientists has used to describe the way solid, liquid, and gases behave using particles. And these particles are not big, they are tiny particles, okay, and the particles are in constant and random motion. Okay, and matter can be classified into good. And in the solid state, we say that they are closely arranged and they are arranged in a regular arrangement, okay, like a cube, like a square, and they vibrate in their fixed position. That means if this one vibrates, it doesn't vibrate to the left, vibrate on top, vibrate below. No, solid particles only vibrate in the same position that they are in. Okay. Now, liquid particles, on the other hand, are also still closely packed, but they are in an irregular arrangement. They move freely, randomly, and they are able to slide past one another. Again, you may want to pause the video to continue completing your concept map. Okay, welcome back. So lastly, we spoke about the third state of matter, which is gases. Now, gases, the particles are far apart from each other, okay, and they are irregularly arranged and they move freely and randomly, similarly to your liquid. The only difference between your gas and your liquid in terms of arrangement is that your gases are very far apart from each other. The particles are not touching each other. They may bump into each other as they move, but they are not close to each other. They are very far away, and in terms of movement, they are traveling at very high speeds. All right, and because of the way these models are represented, solid, liquid, and gases, these models or the arrangement and the movement of these particles basically explains why solid, liquid, and gases have got different properties. And in terms of properties, we are talking about volume, shape, density, and the ability to be compressed. Remember, compress means to push the particles together. And why you can push the particles together is because there must be some space in between. Okay. All right, now let's have a look at some common errors when you are drawing. Now, some of you may have committed some of these mistakes. Please keep calm. Hashtag it is a known error. Okay. So, when you are drawing particles, you must take note of number one, the distance, the arrangement, and the size of these particles. So let's have a look over here. What do you think is the mistake here? This person is supposed to draw a liquid, but he's drawing the liquid at such great distance from each other. So over here, the mistake is there's too much space between the particles. Your liquid particles are still relatively closer to one another. But in this case here, the arrangement of the liquid particles is the mistake because the liquid particles look like they are solid. Okay, they are actually arranged in a solid manner in a relatively fixed arrangement. Whereas over here, you notice that the particles are all different sizes. So this is the error. The particles should be the same size if you're talking about the same solid, same element. Okay, so if you're talking about iron, then all the particles should be the same size because you're only talking about iron. But if you're talking about iron mixed with copper, mixed with aluminum, then maybe you should use different circles since you have three different metals present. Okay, next thing over here, you will notice that the particles are overlapping with one another and they are also sticking out of the box. Now, this is a very untidy way of drawing, and if you do this during the exam, then you will be penalized. So please take note of that. Now, before we go on to 7.2, there are two questions at the bottom of page 3, which I would like you to complete now and take this time to practice. So in the first question, you are supposed to tick the appropriate boxes in the column for solid, liquid, and gases. So for example, under solid, are they close together? Are they far apart? Are they in a regular pattern, or do they move randomly? So you must tick the correct properties, or the correct arrangement and motion for the solid, liquid, and gas. Okay, so can you pause the video and take about 2 to 3 minutes to complete this now? Okay, welcome back. So let's check your work. Under solid, can you guess what is the arrangement of the particles? Good. They are actually, all right, close together, and they are in a Okay, your liquid particles are also close together. What about your gas particles? Right, they are far apart. So now let's talk about the next arrangement for solids. Are they in a regular or a random pattern? What are some of you are saying? Yes, they are in a regular pattern, but your liquid particles, on the other hand, are in a random pattern, and your gas is also in a random pattern. Okay, so this is actually quite a good summary of what we have been talking about in 7.1. Next thing, there's also another question here. So these are the kind of questions that you will usually get for your exam. So you might want to pause the video here and try your best to complete this using the table on page 2 of your notes, okay? So I may want to do the first one with you. So using the particulate model of matter, that means you must talk about the particles in terms of the arrangement or the movement. Give one reason for the following properties. So the property you're talking about here is whether it is able to be compressed. So this particle's property here is talking about whether it can be compressed. Okay. So over here, whether it can be compressed. Over here, taking the shape, that means no fixed shape. Over here, can move from one region to another faster than a liquid. So over here, we are talking about also in terms of movement. Alright, so over here we're talking about whether it can be compressed or not. So this question is saying, how come solid cannot be compressed? Okay, so you must use the model of matter to be able to explain this. Alright, so if I were to do the first question with you, so that you will be able to know how to continue. Why can't a solid be compressed? Now remember, how are your solid particles arranged? Your solid particles are arranged very close together, right? Are there a lot of spaces? No. And if there's no space, can you push the particles close together? The answer is no, because already so close already, no more space to push. So we will say that it is because there are very little spaces between the solid particles. That is why it cannot be compressed. So you look at the way Miss Lee is answering the question. I'm answering the question, why does solid have this property? It cannot be compressed. Why? I'm using the model to tell me that, oh, because it has very little spaces, that's why it cannot be compressed. Okay? So you may want to pause the video here, all right, to write down your answer. Okay, welcome back. Now, what about the next one? We say, how come the liquid takes the shape of the container in which it occupies? Why can liquid take the shape? Because it obviously doesn't have a definite shape. So why doesn't it have a definite shape? It has got to do with the particles. Now, is it talking about movement or is it talking about arrangement? Yes, you guessed correctly. It's talking about arrangement. That is because the particles, okay, the particles are basically irregularly arranged, and in terms of motion wise, it's able to move freely, randomly, and it can slide past one another. And because it can slide past one another and it's able to move freely and randomly, it can take the shape of the container in which it occupies. Okay, you may want to pause the video here for a few minutes for you to finish writing your answer. Okay, welcome back. Last question. A gas can move from one region to another region faster than a liquid. So we're talking about motion here. So let's compare the difference between how gas particles move versus how liquid particles move. Okay, some of you would have guessed it correctly. All right, because gas particles, not only do they move freely and randomly, now freely and randomly, it's the same as liquid. But why is it they can move faster? Because the particles are traveling at greater speeds. So actually, this is actually the key word here. So you may want to take this down in your notes. You might take your highlighter or a red pen and actually know that particles, these two are the same. They also move freely and they move randomly. This is the key word. Alright, this is the one that is the mark. So because they move at much greater speed, they move at greater speed than liquid particles. That is why they are able to move from one region to another region faster. Okay, so you may want to pause the video here so that you are able to complete your answers and scribble down any notes. Okay, welcome back everybody. Now we are going to move on to the second part of our lecture, which is on expansion and contraction of matter. Now, I want you to have a look at this diagram over here. This is a hot air balloon. Now, hot air balloon is basically something where you don't really see in Singapore. Okay, you can see in other countries. What happens is that there are people who are sitting inside the basket. Hot air balloon is very, very big. Okay, it's not your typical kind of balloon. And the basket is actually big enough to hold maybe about 5 people. And at the base of the balloon here is a burner. And this burner actually has got solid fuel. And the person who is in charge of the hot air balloon will turn on the flame, and then the flame will heat the air inside the hot air balloon, and then slowly you will see the hot air balloon actually start to rise above ground and allow people to see, the different sceneries below. Now, why is that so? Because the air in the hot air balloon actually expands. Okay, it actually expands when it's being heated. So we're going to be talking about this in terms of particles later on, but I just want you to have an idea of the fact that when something is being heated, it expands. Okay, now if the air expands, then it will be able to occupy a bigger space. And since it can occupy a bigger space, that's why the balloon from something very small, air is expanded more, becomes big. The hotter the air becomes, it expands even more, it becomes bigger until it becomes so big that it occupies the entire space of the balloon. The balloon is fully inflated and it can actually float up. Okay, so we will be looking at the particulate model of matter to be able to explain this process known as expansion. Now, before we do that, I'll just like you to watch a video that demonstrates this process for us. Okay, so I'm going to ask you to watch a video now.
So I have a hot plate. I'm heating up a pot of hot water. I'm not sticking my hand in it. It's pretty hot. A plastic bottle. When I stick the bottle in the hot water, it's going to heat the air inside that bottle. And you can see almost instantly that this air is actually rising. Well, why is it rising? It's because the molecules of air are heated up and they're actually spreading out. They're spreading out, becoming less dense, becoming lighter. And you can see all the air in this bottle is expanding, spreading out, taking the space up in this balloon. Wow, it's not going to blow up till it pops, but it is expanding. And as that air is heated, it expands and it becomes lighter than everything else around it. So it's taking up more space. Those molecules are moving around quicker, bumping into each other. They need more space. They're expanding. Well, now I have a bucket of ice water. I'm going to slow those molecules down. Drop it in. Almost right away, that air is collapsing, condensing down. You can see there's no air in the balloon because that air sinks. It drops. It's less dense. And all those air molecules are slowing down, coming tighter together. They don't need as much room.
All right.
Now it's almost
So
sucking the
basically, that's
balloon
something that we're going to be
into
talking
the
about,
bottle.
and we're going to be using the particulate
Warm air
model of
rises,
matter to help us
cold air
explain
sinks.
expansion.
Neat concept. Thanks
Okay.
for watching.
So when matter gains or loses heat, we say that the particles change in terms of their movement and change in terms of their arrangement. Okay, so because of the way they change their movement and they change their arrangement, their properties will also be affected. Because remember, we said that properties are affected because of the way particles are arranged and the way the particles move. So if there is a gain in heat, which you saw just now when this guy actually put the plastic bottle which contains air with a balloon that's attached to it inside the hot water, you realize that the bottle number one actually increased in terms of its increase in size, right? It became bigger and became fuller. Okay, and then you can see that the balloon actually started to rise because whatever air that was inside the bottle expand because it was heated. So when you gain heat, it expands, and when it expands, you see, look at Misty's hands. If this is the model for air, if it expands, it will expand this way. Expands more, it expands this way. You notice the space in which my hands occupy is becoming more and more. And so therefore, what will happen? The air will actually occupy more space and it will move up to the balloon. And that's why the balloon actually looked like it was being inflated with air. Inflated means filled with air. Okay, so gain in heat will result in expansion, but when you lose heat, so you see when he actually put the the bottle back to cold water, you saw the balloon went wow, it went flat like that, right? Now why is that so? That's because the gas particles are losing heat, And when they lose heat, they come closer together. And look, when these hands come closer together, I occupy more, I occupy less and less space versus a lot of space. Now I have lesser, 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 lesser space. So the air inside the balloon will become will have lesser space, lesser space, lesser space. It will shrink and eventually the balloon will be deflated. All right. So let's have a look at this. What happens when I heat this? Sorry. What happens? Okay, when I heat this particular model here? All right. So what happens during expansion? All right. Now, if you have a look at this particular diagram here, this particular model that represents your solid particles, what happens in expansion is that these particles will gain energy. Okay, there will be a gain in energy, and you can see that the particles are moving slightly further away from each other. And I want you to look very carefully at the space in which the original, okay, solid actually occupies. Okay, you can see that this is the original space in which the solid particles occupy. This is the original space. Okay, now this is the original volume, right? Now you look what happens when it expands. Sorry, you look what happens when it expands. Okay, it actually occupies more space. It actually occupies more space. And why is that so? Okay, because the particles are moving further from each other because they have now gained in energy. So originally the particles were very close to one another, touching each other. But you know that when it is being heated, all right, the solid actually expands. Now, the particles are not expanding. I look very carefully. The particles are still the same shape. They are still the same shape and they are still the same size. So the particles are not expanding. But what seems to be expanding or becoming more is the spaces in between the particles. So as the particles move further and further, the space in between the particles are increasing. Therefore, the entire solid actually expands, or the gas actually expands. Okay? So we say in science, when matter is heated, the particles gain energy. All right? They gain energy and they vibrate more vigorously. Okay, they vibrate and they vibrate more vigorously because why? They gain energy, so they are able to move faster. Now you know that energy gives you energy is important for movement, right? So the more you eat during PE, you can run faster. Same thing. So when these particles gain energy, gain more energy, they move faster. And because they can move faster, they are able to move slightly further apart from one another with this extra gain in energy. And you notice, okay, if you look here versus here, you can actually see that the particles, sorry, the volume that this matter actually occupies is definitely much more than the volume here, because volume is basically the amount of space a particular matter or an object occupies. So since it occupies more space, the volume actually increases. Okay, so we say that the volume of the matter increases, and this process is known as expansion. So you can see over here, when steel is being heated, you can see that the particles are actually moving, right? And they are moving slightly further apart. And this is actually conduction, in which the particles actually allow heat to be transmitted. Okay, they allow the particles to transmit heat. All right, so what happens during contraction then? Now, from the term itself, expansion needs to become bigger. They occupy a bigger space, so volume actually increases. So what happens during contraction? All right, now in contraction, let's have a look at this diagram here. Okay, you can see that this is when the object is being heated, so it's expanding. So you can see the particles are quite far apart from each other. Now, when these particles lose energy, that means they get put into a colder environment. If they lose energy, what will actually happen? The object will actually contract. Contract means it will shrink in size. Okay, it will become it will occupy less space. So you will notice that the particles actually move back to its original spaces in between here. So you can see that there were more spaces here, but now you can tell that the particles are actually quite close together, right? So if you look at the space, you can tell that this rectangle is much larger than this rectangle. So the space of this rectangle is much more than this rectangle. So the volume here is much higher than the volume here. because volume in science just means space that an object occupies. You may want to write this down, okay, at the side of your notes here. What is the meaning of volume? So shall we take this down? All right, volume means space an object occupies. All right, so over here you can tell that the volume is actually greater than the volume over here. Now, how is this volume related to density? Miss Lee actually told you, right? Now, you learned in chapter 1 that density equals to mass over volume. Now, mass divide by volume. So, if your volume increases in expansion and your mass stays the same, okay? So, let's say your mass is let's say your mass is 10 and your volume is 5. So when your volume increases, it becomes 10 over, let's say, 10. Density here, 10 divided by 5 is 2. Density here, 10 divided by 10 is 1. So you can see that when your mass stays the same, but your volume increases, your density actually decreases. Okay, so what happens during contraction? Now you look at this volume, this space here, okay, is definitely much greater than this space occupied here after the object contracts because it loses energy. So that means in this example, if let's say your mass is 10 and your original volume was 10, okay, let's say after contraction your mass is still 10 and your volume decreases, it becomes 5. So what happens? 10 divided by 10 is 1, 10 divided by 5 is 2. You can tell that your density actually becomes more. So in contraction, when objects lose heat, okay, when they lose energy, their density actually increases because the volume decreases. You might need some time to go back to this concept again, so don't worry, you can always rewind the video and go back to the explanation that Miss Lee has taught you. Okay, so let's continue with the lecture. When matter is cooled, the particles lose energy and they vibrate less vigorously. So therefore, the particles actually move closer to one another. And when they move closer to one another, they occupy less space. So therefore, the volume decreases. Now, this process is actually called contraction. You might want to pause the video here so that you are able to complete the blanks in your answer. Okay, welcome back. Now I'm just going to show you this video that shows you what happens when gas contracts and when gas expands. Okay, so I'm not going to do any voiceover so that you can concentrate in this video. So watch what happens to the movement of the red dot when gases expand and contract. This is the original location of the red dot. In hot water, look at the red dot is moving up, and look at when you put it in cold water, the red dot actually drops. In hot water, okay, now why is the red dot actually rising? Inside the red dot is air, right? It's gas. So when you put it in hot water, the air actually gets heated, the particles gain energy, they move further away from each other, so air expands. Now when air expands, it occupies more space. So when it expands, it occupies more space, some of the air will actually enter this tube here and push the red dye up. When you put this back into the cold water, the air will lose energy, so the particles come close together, so your air contracts, and when it contracts, it occupies less space, and when it occupies less space, okay, some of the air will sink back down into this, therefore this red dye will actually sink. Okay, all right, so now let's go on to the last part, which is found on page 5. All right, what happens to the mass of matter during expansion and contraction? Okay, so I'd just like to let you have a look over here, because you might ask me, Miss Lee, you know, the volume actually increases and the volume decreases when an object is heated or when an object is cooled. So what happens to the mass? Does the mass actually change? All right, so if you look very carefully at this diagram here, you can see that when this key lock, when this lock expands upon heating, okay, the particles become further apart. So you can see that the size actually it becomes bigger, expands, right? Because it occupies more space, right? However, you're not adding more particles to it. So actually what happens, we say, is that mass does not change during expansion and contraction. Okay, although the volume of the matter changes, so only volume changes, mass does not change, because the mass is the amount of particles inside the object. Now, the mass of matter during expansion and contraction is conserved. The meaning of conserved means it stays the same. It is constant. There is no change. Okay? So if you look at this steel log, the distance may change, but you look at the number of steel particles, it does not change. The number of particles are still the same. Cannot be when you heat something, you add more particles. No, the number of particles is still the same because it is still the same object. Unless you are adding more metal to the steel log, then that is different. If you are adding more steel to the original steel log, then of course the mass will change, right? So over here, mass doesn't change at all. Okay, so I would like to show you this animation, maybe it'll be easier for you. See, when I hit this, it expands, but it is still the same particle. It's still the same. And then this green block can enter because it becomes bigger. So the space actually becomes bigger. So since the space becomes bigger because it expands, now this green square block can actually fit into the original shape. Okay, so let's look here. The mass doesn't expand, right? Because why is it expanding then? Not because you're adding more particles, but because the distance between the particles are increasing. All right? Okay, so to end off the lecture, we are going to do two things. Number one, I'm going to ask you to look at question 7.2 under your MCQ. You may want to have a look at this question, okay, and complete this question. So you may want to pause the video. You may want to pause the video now. Okay, so welcome back. Now the question actually asks you, which of the following occurs during expansion? Okay, the particles of a substance lose energy. This happens in contraction, right? The particles of the substance move further apart from each other. Sounds logical because now the particles got more heat energy to vibrate faster and therefore it can move further away from each other. C, the number of particles of a substance increases. No, the number of particles can only increase if you add more matter, but you are not adding matter, you are just heating matter. Or D, the size of the particles of the substance increases. Do the particle size increase? No, right? It is the distance, right? So therefore, the answer should be B. Okay, now this is a very common exam question, so you might want to put a star next to this question here. Okay, so let's end our lesson today by going back to page 17 on your concept map. So we basically said that when you heat an object, it can gain. We talk about heat gain and we also talk about heat loss, right? So what happens is that heat gain and heat loss can result in expansion and contraction. Okay, now in expansion and contraction, what will happen? Volume changes, but mass is conserved. Conserved means it stays the same. So the space that the object occupies will increase or decrease depending on whether you're talking about expansion or contraction, but the mass of the object still remains the same. All right. Okay, set ones, I hope that you have enjoyed this lecture. I know it's a little bit long because we covered two very big concepts. Now, your teachers will actually have a live Google Meet session with you. So you might want to raise some questions that you have with them. And then later on, we will actually post the answers for practical pages 91 to 93 for you to actually mark your practical workbook. All right. Thank you very much. We will see you in the next lecture. Goodbye.